It's M H370. Until you do some research, don't talk to me. I'm going to find the truth while I sip this martini. Your opinion, it means squat to me. It's H370. Not all heroes wear capes. I wear glasses to see. I'm going to find the truth while I sip this martini. The trolls hate seeing me succeed, but guess what? H370. Guess what? MH370. Not all heroes wear capes. I wear glasses to see. I'm going to find the truth while I sip this martini. Your opinion, it means what to me? Your opinion. H370. Not all heroes wear capes. I wear glasses to see. I'm going to find the truth while I sip this martini. The trolls hate seeing me succeed, but guess what?
What's up, everybody? Welcome to the stream tonight. It's technology tonight, everybody, with Ashton Forbes. Hope you guys are excited. Welcome, everybody. Thanks for being here early on. I appreciate it. So we have new streaming time, new streaming hours. Going to be 8 o'clock Eastern time, 7 o'clock Central time, 5 o'clock Pacific time. I don't know. Pacific time doesn't matter to me. Just kidding. And if you're somewhere else in the world and it's early morning, well, thank you guys for being on here as well at this time. We are also going to be streaming Monday, Wednesday, and either Friday or Saturday, depending on my social schedule. Probably will be Friday, but we'll see. So I'm trying to nail it down a little bit, guys. The reason for kind of doing less streams is that I can't keep up. It takes a lot of work to prepare for some of this stuff. And I'm basically already working like 3 jobs, maintaining my old job, doing social media, which has been difficult, and then also the EtherTech stuff as well. For people that are curious, yes, the EtherTech stuff is still going on. I'm in communications with a number of people at the moment, and I'm not really going to post any more information about it. All contracts, all discussions, everything related to that is private, and that's how it's going to remain. So if I do have other things that I can talk about publicly, I may do that, but I just wanted to give you guys a quick update in terms of why you haven't heard anything related to that. Hello, Sassy. Hey, Chaotic Good. Hope you guys are doing well. I saw Gerald in the chat up there earlier. Saw a bunch of people up there. So thank you guys for jumping in. So what are we talking about tonight? Tonight we are doing science. We are first going to watch this video related to waves. What did I call it again? I keep forgetting. Basically like wave theory. It's a pretty interesting video that came from AT&T's archives. Where do I have it here? Wave behavior. Really cool. I haven't finished the whole thing. I only watched probably the first 15 minutes of it or so. We're going to watch that. And then I've got a number of different things we might do after that. I haven't really necessarily decided. There's a couple interesting scientific papers that I was looking at. This one related to the Casimir effect, or we may just jump in and there's some videos showing the EM drive experiments, which I haven't already reviewed. So that might be a mystery, guys. So we'll see. Should be fun, everybody. Yeah. Hey, Sacred Geometry. Hey, Mario. Hey, everybody for hanging out. Okay. Part of the reason to do earlier as well is I've been staying up too late, so I want to have these streams end a little bit earlier so I can get some good sleep. Oh, and actually that reminds me, we probably will look back at the teleportation physics study there was a couple parts in the teleportation physics study that we had kind of missed. In fact, I'm gonna pull that up for later. Because we had focused a lot on the VM teleportation. There may be another kind that is pretty interesting and pretty relevant as well. Okay, what is going on with this? Oh, I accidentally fast forwarded. Hold on. Okay, that's what was going on there. Sorry, guys. Give me just 1 second. I'm setting up the stuff that I want to look at here. Put that here, and then we'll put 0 point energy over here as well. Okay, great. Okay, so if you guys are ready, here we go. And before we do that as well, I made this post yesterday about gravity manipulation and what have you. Um, like, just what I want to say, just kind of personally, is like I'm already about as certain as you can humanly be that free energy, gravity manipulation, space time manipulation are all real. I've already started to hit the point where you've learned enough where you're like, okay, it's definitely legit. I don't even talk about a lot of the stuff that I know behind the scenes as well. So what I present to you is it's a good amount of what I know, but there's other stuff that I probably will never be able to talk about. And that makes me beyond certain that some of this stuff is possible. And I've already begun to hit that point, and I've already begun to hit the point where I probably have to be a little bit careful about what I say regarding certain things, which is crazy. If people want to think that I've made some kind of deal or got my Scarlett Johansson clone, you're certainly welcome to think that. I'm not going to stop you. I don't care. But no, I have not been ever told by the government or anything like that. It's more of a situation of where like I've just realized what the situation is, like much better than I knew about like a year ago. A year ago, I thought the media would pick up on this. I thought the world would talk about it. Now I'm at a situation where it's like, okay, not only is all the media suppressed, but I wonder if it's even safe for this technology to come out. And I've done my best to try to disclose it. I think I've been relatively successful. I mean, a lot of people would kill for as many followers as I have on any social media platform. And that's just because of all the work I've put in from going on podcasts and discussing it. The world is clearly not ready, clearly not awake enough yet to realize that this technology is real. And that's totally fine with me. I'm not trying to convince everybody. The fact that you all understand that it's real is good enough for me. It makes me happy on the inside. And like I've said many times over, is that you can profit off of this information in probably multiple ways. So I encourage the people that know to do their own research, to verify the information. The last thing I'll say is all of the science is out there. All the information is out there. Um, it's hiding in plain sight. That's the funny part. All the science related to 0 point energy, even gravity waves, everything, it's all out there. You guys have seen me show a lot of it. So if you want to figure it out, you can watch my streams, what have you. You can go do your own research and find it. Um, and I think the question you should ask yourself is, why is there all these scientific papers around this topic that mainstream physics just simply doesn't accept? So the rest I leave to you guys to figure out. Okay, I need to move this one over as well, actually. I'm gonna move that one there. Okay, here we go. So let's go ahead and watch this wave video. This video is like almost 100 years old, or 80 years old or something like this, like from the 50s, I think. It's totally wild. For the answer to Nick, I would say this is as much as I feel comfortable saying. I would say that it's not as simple as the right hand rule, although every engineering concept is very important. Electrical engineering is definitely where the secrets are. And then what I would say is you should probably look at the researchers who researched anti-gravity. We call it anti-gravity, but I call it gravity manipulation because that's a better term for it. So just look at the researchers that researched anti-gravity. I mean, it's all out there. What more do you want? And you'll realize in the same way where we look at a lot of these over unity concepts, and like there's just there's no comprehensive review of most of them that are out there. You should, when you see that, you should go, why is there not? And you should ask the same thing of these gravity researchers. Like, nobody's debunked these people's work. So what's the deal? Why are we paying no attention to it? You know? Anyway, I'd take a look at that. That's as most I feel comfortable saying at this point. But like I said, it's 100% possible, guys. 100% is possible. About as certain as a human can be at this point. It's pretty wild. Okay, and last, I guess I said last thing, but here's the real last thing: is that I don't know what this all means. Like, I don't know. I weirdly, and definitely check out the podcast I did with Health Ranger, Mike. I think that one that's drops probably going to be one of the best that I've ever done, up there with Redacted. I don't know what this all means. I actually don't even care about aliens or UFOs anymore. That's what's so crazy is once you learn about the science, you're like, well, I don't care about floating objects and shit like that. We can do so much more than that. Like, that's, just doesn't excite me anymore. So reason why I want to learn about waves is that I do think that the waves are definitely very, very important when it comes to electromagnetism. You're going to see it very quickly during this video. And I think it's very important to have an extremely intuitive understanding of it. And I'll do some commentary as we watch it here. So first thing, I'm going to see if I can play this with sound with it being fast forwarded. If not, we're just going to have to watch it in slow-mo. So let me take a look here and see if this will let me share it. Share screen. Oh, God. Oh, these are Chrome tabs. So yeah, it doesn't. Okay, I guess I have to share it in like the slow-mo way. Okay. Annoying. Video file. Wave behavior. So does anyone know, like, is there a way to make it go fast forward here? Like, I can mute the video, full screen layout. There doesn't appear to be any way to make it go fast forward. So I'm going to skip part of this first part. Basically, it just explains that this is something from their archives. So here we go, guys. This video is awesome, everybody. Oh, yeah. Danny Sheehan talks about it. I mean, Danny Sheehan's mostly on the money, but all these people, I think the fact they focus on the alien stuff is kind of a big distraction. Like, why the hell does everybody care so much about aliens? Oh, we're not alone in the universe. Okay, well, here you go. Spoiler. We're not alone in the universe. There's definitely life somewhere out there, okay? If they're visiting us, the question should be like, how are they visiting us? Oh, so, hey, Jeremy. Have you seen this, Jeremy? Dr. Shive? I mean, this video is fucking crazy, chat. This is such a good video. Yeah, so the thing I like about the APEC guys, I've been singing their praises a lot. They're trying to figure it out on their own. They're trying to figure it out open source-wise. Like, here's what I would say for Jeremy. This is what I feel comfortable saying is, like, just be careful, man. Like, there's a reason why this stuff has been hidden so long, and they don't want people open sourcing it. Like, let's just look at like Amy Eskridge, right? She was trying to get it open source. She was trying to, in my mind, she's a spiritual successor to Potkanov and Ning Li. So, just be careful. That's all I got to say. But I do think that I think that those guys can figure it out for sure. I think they can figure it out. Shive wave machines. Yeah, I kind of want one of these things, guys. Here we go. Let's watch this. Yeah, one thing I realized too, and this may be of use to Jeremy, is when I was looking through, I was putting together a lot of the podcasts that I've been on, and I noticed that Tim Pool broke it up into like 15-minute segments, and then each 15-minute segment did like really well. That's probably a good way to do it. If you guys can do it, that'll probably help. Because problem is, like, honestly, even 2 hours is too long for a lot of people to watch. I feel like that we're in the world of TikTok right now where nobody's watching anything that's over like, 10, 15 minutes. So that might just be some help to get more engagement. I think that a lot of it's about gaming the engagement system. Okay, guys, here we go. You guys ready for this? 1959, guys, Bell Laboratories. John Shive. What a video, man. I can't believe like there's so much stuff like this out there. 1959, man. Like the world, like this, the Carl Sagan quote. We live in a world of that's driven by science and technology, where no one understands the science and technology. I'm happy that I've started to learn it. I feel like I've come a really long way in just 8 or 9 months, but I'm nowhere near where the experts are in the science and technology. And look at this device he's got going here. I'm gonna probably go put this in full
People who
screen
study
on my side.
waves extensively in the various fields of physics and engineering are impressed by the similarities which exist in the behavior of waves in various mechanical,
Chat, I want one of these devices. Just wait till you see this device rocking.
electrical, acoustical, and optical wave systems. These similarities are due, of course, to the basic fact that waves of all kinds behave fundamentally alike.
We're gonna go faster.
These two rib-like structures are mechanical wave demonstration machines. With them, I can show you many of the various wave properties which you may have studied experimentally or theoretically, perhaps without ever having actually seen what the waves themselves are doing. The waves which travel on this machine are really waves of twist or torsion, which propagate along this central wire. Attached to the central wire are these cross arms, which translate the torsional motion of the central wire to the up and down transverse motion of the ends of the cross arms, which you see. The entire structure is supported in a set of bearings which permit the central wire to twist freely. This second wave machine is built similarly to the first. It has cross arms which are considerably shorter than those on the first machine, and as a consequence, the speed of a wave along the second machine is about 3 times faster than the speed of a wave along this machine. You'll see later on why
I love how the one machine, because the arms aren't as long, the waves travel 3 times as fast. So right away, pretty cool, huh?
I have these two machines. First, I want to show you the two different ways in which waves may be totally reflected. Observe that right now this machine has a free end. That is, this last cross arm is perfectly free to move without restraint. If I start a wave at this end of the machine, that wave travels down to the far end, is reflected there, and returns as a reflected replica of its original self.
Already awesome. I mean, already awesome. Yeah, the wavelength is inversely proportional to the frequency. The longer the wavelength, the shorter the frequency, etc. If you're not familiar with that, the fact that it's a reflected wave, I think, is very important and very cool. I know that's important. I don't know exactly why.
But now let me terminate this machine in a different way. I'll clamp this last cross arm to a heavy stand so that a wave arriving here can't produce any displacement of the cross arm. This time you see the wave is reflected upside down. The reflection is still total as it was before, but the wave is inverted upon reflection.
Look at that. Holy crap.
In a mechanical wave system, then, there are two ways in which the total reflection of waves may take place. Right side up, if the reflecting end of the medium is completely free, and upside down if the reflecting end is completely restrained. Now, if nature has any consistency, and we like to think she does, this alternative reflection possibility should exist for waves of all kinds, and these other drawings here show that indeed it does. Take the case of an electrical transmission line, for example. You know that there are two ways in which electrical waves can be reflected, depending on whether the far end of the transmission line is terminated by a short circuit or by an open circuit. And similarly, in the case of waves traveling down an acoustic tube, there are two different reflection possibilities, depending on whether the end of the tube is closed by a rigid termination or by the acoustic analog of a free end. Note that in the mechanical situation, a clamp is a constraint preventing the displacement of the end of the wave medium.
I need some analogies here because the circuit, I mean, it looks like what he's describing here is if the circuit is open where you have to have the electrons jump versus a situation where it's completely closed off. And then with the acoustic wave, I'm trying to think of instrumentation and I don't quite understand it, but Pretty neat.
The electrical analog of this state of affairs is an open circuit termination on the end of a transmission line, preventing the flow of current at such a termination.
Okay, so it literally is. It is just an open area. It's preventing the flow of current. Okay.
And the acoustic analog is a rigid closure at the end of an acoustic tube, preventing the longitudinal vibration of the air. In all of these
Yeah, it sounds like it's like a muting a trumpet. Yeah, basically is what I'm imagining. You put something in there to close it or something, I guess.
cases, the reflected waves come back upside down. And in all of these other cases, conversely, which are analogous to the case of the free end of a reflecting wave medium, the reflected waves come back right side up. You see, nature really is consistent. Well, now let's have a look at some of the other things we can do with our wave machines. One of the most important topics in the general development of wave behavior is the principle of superposition. When two waves traveling in opposite directions on the same medium, as you see here in slow motion, pass through each other,
This is cool.
the instantaneous amplitude of the resultant wave is the algebraic sum of the amplitudes of the two constituent waves.
So you just sum the waves together. If two waves are on the same side, both are like above, and they come back over, amplitude's gonna just add together algebraically.
This principle of superposition is equally valid when one of the two waves is positive and the other one is negative. Observe that in this case, at the instant of exact coincidence, there is a momentary cancellation of the amplitude,
This is cool.
and the medium appears to be undisturbed.
Look at that. Completely cancel each other out.
Now let's have a look at the superposition behavior of continuous trains of periodic waves. With this small motor and crank, I can generate such a train of waves at this end of the machine and reflect them back upon themselves at this end. All right, in slow motion now, here come the waves.
So I think he clamped the backside. Yeah.
After reflection, the waves travel back up the machine, superposing on the oncoming waves which they meet to produce patterns of built-up amplitude at some places and complete cancellation at others. The pattern that you see on this machine appears to be standing still, doesn't it? The various portions of the medium simply bob up and down in place without giving you the impression of motion in either direction along the machine. Observe.
Yeah, it doesn't even look like it's moving anymore because of it. It's gotten to like a harmonic resonance. It's so odd. And then you can imagine it's going to get weirder too here in a second because you can start to manipulate the wavelength. Interesting. Yeah, I'm definitely interested to see that device that they're setting up. Cartesian representation of a wave propagation doesn't account for the phase shift. Okay.
Observe that in this pattern, there are places where the medium appears to be standing completely still all the time.
I'm not sure about the phase shift thing. We may have to look that up. I'm just gonna. Yeah. Okay. Interesting. I think he may address it. We'll see.
These dead spots, or nodes, are exactly half a wavelength apart. Now, I'm sure that you've all seen behavior of this kind before. For example, a vibrating string always vibrates naturally in one or more segments separated by such nodes. Now let me show you something else. Suppose I simply move this reflector a short distance up the line toward the
This is really cool.
generator. Just far enough so that the travel time of a wave down and back is an exact multiple of the wave period. Under these conditions, the new waves which are continually being sent out by the generator superpose upon the previously emitted and multiply reflected waves in just the right phase to build up the amplitude to an abnormally large value, new crest on previous crest, and so on. The system thereupon becomes resonant, and the amplitude builds up to the noticeably larger value that you see here. Under these conditions, the new energy which is being fed into the system at each cycle is exactly equal to the energy which is being dissipated per cycle through friction at this new amplitude. Now, the initial adjustment which I made in the length of the machine to produce this resonant condition is called tuning. I could just as well have produced resonance by leaving the line at its original length and tuning the frequency of the generator instead.
So this is how you tune it, okay? So you can basically determine how long it's going to be on either end, or you can change the frequency of the machine that's bobbing up and down.
And I can destroy the resonant pattern that I have here by changing the value of either of these parameters a little bit in either direction.
There's like a whole graph for like tuning your device with an electrical engineering graph. It's a big circle, I think, right? It's got these arcs all over it. I think that's what this is for.
Another way of looking upon a resonant system is to regard it as a reservoir for energy. Thus, the escape wheel of a watch, a child's swing, a sounding organ pipe, the resonant circuit of an electrical radio transmitter are all examples of resonant systems. They exhibit abnormally large amplitudes of oscillation, and they possess relatively large contents of energy which have been built up by superposition over many previous cycles. Now, from here, I want to go on to the subject of the impedance of the wave medium. The generation of waves on a transmission line of any kind, electrical, optical, or what have you, involves two parameters, an originating cause and a resulting effect. In an electrical transmission line, for example, the cause of the waves is an AC voltage applied to the input end of the line.
So the cause is your voltage. That's I don't know what symbol that Greek symbol
The result
is. I gotta work my Greek symbols, chat.
is an AC current flowing into the line.
Okay. So
The
voltage
ratio
and
of the
current.
cause to the effect is called the impedance.
It's new. Okay,
You're
thanks.
probably most familiar with the term impedance through your studies in the field of electricity. But this impedance concept is just as applicable to wave systems of other kinds as well. On our mechanical wave machine there, for instance, the cause of the waves is the oscillating torque which I apply to the first cross arm, and the result is the oscillating angular velocity imparted to the medium. On that structure, then, the impedance, the mechanical impedance, is the ratio of the applied torque to the resulting angular velocity.
Torque over angular velocity, yeah.
In terminating the other end of a transmission line, we frequently seek to adjust the impedance of the terminating load to equal the impedance of the line itself. When this is done, all the wave energy traveling down the line is absorbed by the load and no reflection takes place.
Yeah, this is what they use that graph for. I forget what it's called. There's this chart, circular chart. If you guys know what it is, put it in the chat. But this is what they use it for, is to make sure that like all the energy flows to the load or to like the antenna or whatever you're sending out, so that it doesn't reflect back.
The load is then said to be matched to the line.
Impedance matching, is that what it is? Let me. Yeah, there it is. Found it. Smith chart. Smith chart. Got it. I was right. Damn, guys, I'm starting to learn stuff, chat. We're learning out here today. Smith chart. Yeah, look at you. Look at you guys. Gold star for Steve Goslin tonight, everybody. Resistance is linear impedance, while capacitance and inductance are phase and time dependent. Man, you got to be really smart to even understand this stuff. I feel like this is tough.
Now this matching...
Yeah, like right away, and we know the answers to the test, right? So if scalar technology is real, it's a matter of trying to find the exact right position where you have your wave perfectly cancel itself out, your electromagnetic wave. It's either you're, and maybe there's more than one way where like you either have it amplify or you have it just completely cancel out. And then you have your phase set where the impedance basically becomes 0. And now it looks like you're transmitting nothing, but you're electromagnetically, but you're still transmitting your scalar potential. At least that's how I imagine it. Maybe I'll be right. Maybe I'll be wrong. We'll see.
Condition can be demonstrated very nicely with the wave machine here by attaching to this last cross arm a mechanical impedance and adjusting the resistance, the counter torque, with which that impedance reacts back on the motion of this cross arm. Such a mechanical impedance.
This is about as far as I've seen, so that's funny. He said apparently he's going to show it. Here we go. I love it.
This is afforded by this dash pot, simply a tin can full of water with a little piston pumping up and down in it.
What?
By sliding this dash pot in or out along the last cross arm, I can control the counter torque with which it resists the displacement of the medium, and thus match the impedance of the dash pot to the impedance of the transmission line.
Oh, he's going to do it right here. This is going to be awesome. I'm so excited for this. Because, yeah, I mean, imagine that we've got radar technology. So we figure out radar technology and we start shooting electromagnetic waves. And then we start figuring out, well, what can we do with this? How far can we push this? How can we manipulate this? How can we tune this? I mean, this was 1959, right? So, boy, have we probably figured some shit out.
Itself. When this adjustment is properly made, the dash pot absorbs all the wave energy that travels down the line.
Yeah. Oh, this is going to be sweet. So instead of it just being like oscillating, it's going to look like it's moving again. And then it's just going to die when it gets to the end point here. This is going to be awesome.
And as you can see, hardly any perceptible reflection takes place.
No reflection. Look at that. Oh, my God. Yes.
Now, instead of using single waves, suppose we have a look at this behavior with a train of continuous waves.
Yeah, here we go. Oh, this is going to look sweet. Oh, I'm maximizing
Here you see such a train of waves.
Now it looks like it's moving again.
Down the machine from the generator to the load and disappearing into the dash pot.
So where's the energy going? It's going into the dash pot.
Now suppose I spoil this nice matching adjustment by moving the dash pot farther in toward the central wire. The impedance of the load now no longer matches the impedance of the transmission line, and a partial reflection of the wave energy occurs.
It's not a full reflection, only a partial reflection.
Let's have a look at this partial reflection now with continuous waves instead. We expect some kind of standing wave pattern to appear on this machine now, don't we?
Yeah.
After all, we have running waves going in this direction and returning waves.
So that's what a standing wave is. So when it looks like it's just oscillating up and down, you've created a standing wave. But when it looks like it's moving and it's absorbing the energy at the end point, now you've still got your transverse moving wave or whatever.
Coming in this direction of the same period on the same medium, only this time the returning waves have the lesser amplitude because the reflection down here is only partial. Well, I do see a standing wave pattern of sorts.
Yeah.
Here are the nodes, half a wavelength apart. Only notice now that the nodes are no longer standing still as they were in the case of 100% reflection. Suppose I have the camera speed up the picture for you so that you can see what the envelope of this standing wave pattern looks like.
This is so weird. It's almost jittery, right? Huh. Like I can already tell there's like a connection to cymatics, right? With cymatics where like you get now if you get into your certain harmonic frequencies, now you're going to see your standing wave patterns. You're going to have this coherence. Very, very interesting. Yeah, it's a bit of a Yahtzee moment. What's this video called? I don't know. Something about wave behavior with AT&T. I don't have the link handy at the moment. I closed it. Tacoma Narrows Bridge. Amplitude of the standing waves exceeded the maximum deflection rate for the bridge, and then it just fell apart, probably. Yeah. Interesting. Yeah, that's part of the problem too, is like especially with like a suspension bridge, it's going to oscillate. starts to oscillate too much and you start to develop standing waves, your bridge just collapses. Yikes. Scary stuff. Pretty cool. Yeah, so ever since the bridge collapse, engineers have been taught this in the concept of the dash pot. God, the crazy fact is, like, even engineers probably struggle with this concept. Like, this requires like some pretty powerful, like three-dimensional or like extra, thinking outside the box. I don't know what the right word is. Maybe like not intuitive, but like ability to perceive what we're talking right here and visualize it in your mind. Video is called AT&T Archive Similarities of Wave Behavior. There you go. If people want to check it out. Okay, here we go. Yeah, honestly, same thing probably happens with my chair. Why my screws were falling out of my chair. Pretty weird. Cool stuff. Differential equations. Yeah.
Now let me draw you a sketch of that standing wave envelope. The amplitude at this point I'll call A sub maximum.
A sub minimum.
At this point, A sub minimum. Now in wave theory, the ratio of A max to A min has a particular significance. It is called the standing wave ratio, abbreviated SWR. On the wave machine, the standing wave ratio is about 3 to 1. Now recall that when we had 100% reflection, when the end of the machine was clamped, we obtained a standing wave pattern with motionless nodes. The standing wave ratio in that case was infinity. On the other hand, when I had a perfect impedance match, there was no reflection at all and no standing wave pattern. Yeah. In that case, A max and A min were the same, and the standing wave ratio was unity. Now I think you can begin to see where I'm leading you. The punchline is this. In any practical case of reflection, a measurement of the standing wave ratio on the medium just ahead of the termination enables one to calculate the percent reflection that is taking place there. The complete expression is percent reflection is equal to the standing wave ratio minus 1 squared divided by the standing wave ratio plus 1 squared times 100. Now just for fun, let's measure the percent reflection that's taking place here. With these identical scales, I can measure the amplitude at a maximum and at a minimum of this partial standing wave pattern. Maximum 5, minimum 2. If you and I agree, the maximum amplitude we saw there was 5 units, while the minimum amplitude was 2 units. Therefore, the standing wave ratio is 5/2. Substituting in the percent reflection formula, we obtain percent reflection is equal to 5/2 minus 1, which is 3/2 squared, divided by 5/2 plus 1, which is 7/2 squared, which gives us 9/49, or about 18%. Now note that I have just calculated the percent reflection on a mechanical wave system using an expression that was first developed in the field of AC electricity. Now this is a perfectly valid and logical thing for me to do, since waves of all kinds behave alike. Now let me develop for you another idea.
So for people who didn't follow what he just did, it's simple math is just determining how much the wave is being reflected. So what's the total percentage of the wave that's being reflected? And that's based on where they take the pot and where they put it along the beam that's moving. You can get to a point where there's nothing that's being reflected. And usually I think that's the ideal state, is you want no reflection, because that means that all the energy is transmitting to the load. Your load could be an antenna that you're shooting your electromagnetic, your radio waves out, any type of waves. And any amount that's being reflected is then, wasted, essentially, if you want to think of it like that. And so I'll just quickly show you. I don't know if he's going to show this Smith chart. I'll just show you this Smith chart real quick that I've got. This Smith chart is how you calculate it in terms of how to figure out, where this is how you use your impedance chart. I don't know exactly. I forget. I listened to an explainer on this, but maybe we'll watch the explainer afterwards. But this is how you can kind of use this Smith chart to figure out like where you need to put that bobbing, what do they call it? The thing with the water in it. This is how you figure out where you need to put it in order to get it so that your reflection is the minimum possible. Because what people are trying to achieve is what's the minimum reflection so that basically nothing's being reflected back. There, I think he calculated it was 18% reflection.
Waves are partly reflected not only at mismatched terminations, but also at places where the impedance of the transmission medium changes abruptly. Suppose I connect these two wave machines end to end. Together, they give me a single transmission line made up of two pieces having different impedances.
I don't know if it's a harmonic. I mean, the idea is that you just put it at a spot based on the wavelength and based on the frequency. So it's going to be variable. It's not one spot you put it at the end. It's highly dependent on where your frequency is of your wavelength. So that's one of the variables on the Smith chart.
At this point,
yeah, so the reflections are thought of as lost in the system. Impedance matching is how they reduce the loss and guarantee a clear signal. So essentially, the loss energy is essentially the noise, huh? Yeah, and then water and air, since they're different mediums, have different wave speeds. Technically, you could argue the space and medium has different wave speeds as well, but we experience space uniformly everywhere we go at the moment.
Where the two central wires are clamped together with this little clamp, there is an abrupt discontinuity in the impedance.
Oh, this is going to be cool. He's connecting the two of them.
Of the transmission path. A wave traveling slow along this medium will suddenly speed up when it crosses over into this one. This behavior is similar to what happens to a beam of light when it emerges from glass into air.
Here you go. Here's what Jeremy was just talking about. So now he's changing the medium basically. So if it goes from water into air, air into water. So yeah, water, it's going to be slower. Air, it's going to be faster. So the water is essentially, imagine the water medium is the longer one's the first one here. And then the air is the other one here. Pretty cool. So this is interesting to know. Electronic radios are tuned via a varicap or variable capacitor. Interesting.
Now, before I show you what I want to show you, let me clip this dash pot down here.
Oh, this is going to get really interesting. Because the fact that the wavelength changes means that he needs to tune it towards the second medium here. You know what? I'm just going to play it out and see how this plays out. I'm not sure. So moving the varicap will isolate the radio frequency that you want to tune it to. Makes sense.
In a matching position to prevent the unwanted reflections from this end. It's this point here that we're really interested in.
I'm maximizing this. I want to see.
All right, here comes a wave. And there it goes.
Oh, it reflected initially right there.
Again?
It reflected when it hit the medium. Reflected and then died up at there. Wow.
Do you see the reflected waves coming back from the midpoint here?
Yeah.
Now that I've warned you what to look for, this time you watch for that reflected wave coming back.
I saw the reflected wave right away, right there. You see it?
Yeah.
Huh.
And once more. There goes the main wave. Here comes the partly reflected wave.
Huh.
You know, our world simply abounds in examples of this kind. Electric waves, light waves, sound waves, mechanical waves are partly reflected when they encounter impedance discontinuities. Usually in situations of this kind, however, continuous waves are involved. After I connect up this motor,
Oh, this
we
is
can
going to be
see what
wild.
happens when continuous waves meet an impedance discontinuity. As
So
we
impedance discontinuity is weird. I wonder how that's going to work out. Huh.
might expect, a partial standing wave is
Yeah.
produced. If I wanted to determine how much energy is reflected there, I could measure the maximum and minimum amplitudes of the envelope and calculate the percent reflection by the standing wave ratio method we used before. That expression is equally good for calculating the energy loss at any kind of impedance mismatch or discontinuity. Often in our technology, this partial reflection of wave energy by impedance discontinuities in the transmission path is economically wasteful, and we seek to avoid it by inserting some kind of impedance matching device between the sections of the medium bordering the discontinuity. Here is an example of such a mechanical impedance matching device. It is simply a short section of the wave medium, exactly a quarter of a wavelength long, and having a cross-arm length intermediate between the cross-arm lengths of the two machines. It is called a quarter wave matching transformer. I'll sandwich it in here
Well, this is cool.
and then show you how it operates to promote the transmission of wave energy across this discontinuity without reflection loss. All right, here comes.
That's an interesting point. That's why when you go underwater in a pool, the surface looks like a mirror. Huh, because the waves are reflected through the medium. If you go the other way, you get a total internal reflection. So water into air. Yeah. Wow. This is wild. It's very important to understand this, I feel like. Quarter wave impedance transformer. Yeah, that's what he said. Okay, let's see what happens here.
The waves, and now you watch what happens. And there they go. There is no perceptible
Wow.
partial standing wave on the
Standing wave's
input portion
gone.
of this transmission system, as there would be if reflections were coming back from the junction. Apparently, then, I have matched the impedances of these two machines.
What the F?
This kind of transformer has a direct analog in optics. The non-reflecting coating on the lens of this camera is an optical quarter wave matching transformer. It works in precisely the same way with light waves.
Interesting.
Now, unfortunately, this type of transformer suffers two major drawbacks. It operates only for continuous waves, and it is effective only for a narrow range of frequencies, including the particular one for which it was designed. For applications in acoustics, mechanics, shortwave radio, and the like, where it is desired to accommodate much broader ranges of frequency, we have a different kind of matching transformer, to which this megaphone is a first approximation. Now, the megaphone smooths over the impedance discontinuity between the air column in my throat and mouth and the free air in the space around me by means of a gradual taper. The mechanical analog of a megaphone is a section of the wave medium whose
Look at that.
cross-arm length at the two ends matches the cross-arm length of the two machines that I am trying to couple together.
The solution's so simple, right? So instead of just taking a device, it's like half where the arms are are right in the middle between each section. So you got your two sections, and you have this middle section is half the length between of the difference or whatever. You just make it so that it's tapered. If it's tapered like a cone, then it solves your problem. Then it'll work for a wide range of frequencies. Wow, this is sweet. What an elegant answer. Seems obvious in retrospect.
with a gradual taper in between. A
Hey, look, he just said taper. Perfect.
tapered section transformer such as this will match impedances over a relatively wide band of frequencies. It is effective also for use with single waves and pulses. Watch what happens now
This is good.
when I send a number of pulses down this line.
Yeah, we're definitely going to lose our standing wave here.
Here comes a short, quick one. And you see that hardly any perceptible reflection comes back. Here comes a somewhat longer one. And again, only a small amount of reflection returns.
Yeah.
You see, the tapered section transformer is really a relatively broadband device.
Huh.
Here is another example of a tapered section transformer. It is a piece of waveguide used to couple a section of rectangular cross-section waveguide to another one of a smaller cross-section in such a way as to prevent the reflective loss of radiation. In electricity, we employ transformers ranging all the way in size from this little fellow you can scarcely see, clear up to the big transformers almost as big as houses that you find in hydroelectric stations.
I have a feeling that we can make these things like smaller than my nail.
Even nature herself is in there pitching. Inside the mammalian ear, there are three tiny bones called the hammer, the anvil, and the stirrup. Their task is to provide an impedance linkage between the low impedance of the air in the outer ear and the high impedance of the liquid in the inner ear. And in addition to all these transforming devices that are used with pulses and waves, there are others that are employed with unidirectional motion. For example, in mechanics, all of the mechanical advantage machines, such as gear trains and levers and pulleys and the like, are really impedance transforming devices. Now, in this film, I hope I've been able to present you some different approaches and perhaps to lead you to a few new insights. One thing that has always profoundly impressed me is this: waves of all kinds behave alike. And if through any process you choose, you can learn the fundamentals of wave behavior, either through the study of some discipline in which waves play an important role, or even through the study of waves for themselves alone, then you will always feel at home in any branch of physics or engineering where the main show has to do with waves and how they behave.
Wow. Damn, one of the best science experiments I've ever seen. Pretty incredible. Waveguides plus over unity can equal the generation of counterspatial nodes. Definitely seems to be a connection there to some degree. I'm still wrapping my brain around it. Yeah, wow, one of the best ones I've ever seen, honestly. Great video. Man, good stuff there. Okay, let's remove that. So I think that learning about waves is vitally important for understanding physics and electrical engineering. Everything. I mean, you could argue almost everything is waves to understand it. The fact there's a wave reflection at all seems really important. Equal and opposite reaction. And the fact that we can manipulate it is also really important. Wave matching is a great tool for sure. I almost want to watch, like, I want to learn as much as I can, and then I want to rewatch all the Thomas Bearden videos after I have a much better understanding of electrical engineering. So here again is the Smith chart. Let's see if I can pull up a big one. Yeah, here it is. And so this is where you basically use your wavelength to figure out what the impedance is going to be and where you have to set it in order to get basically zero reflected wave. You're trying to achieve a minimum reflected wave. And this is how you figure it out. Determining the impedance from the Smith chart. Add in a series of L and C values. Add in parallel L and C values, shifts the point along the reactance curves. Yeah, okay. to verify your impedance magnitude chart. Interesting. Okay. What do you say? Yeah, those charts are pretty rough. Watch Walter Lewin explain wave math on MIT OCW if you want to see another master professor. Okay. It might be something I'll look into later. Put them down in my notes. Walter Lewin. If anyone can find any good videos by him, let me know. One sec. Delete this. Oh, I gotta. Oh, okay. Oh, here's the videos we were gonna watch as well. Okay, I think let's see what else we can get to here tonight. We're about halfway through for tonight. The phase shift is the displacement of the waveform in time. Yeah, okay, I don't think I need to look at too much of that. I want to look at this 0-point energy document here from 1999. I don't even remember where I got this. Oh, later, Bernie, if you're taking off. Brother, peace, man. I'll send people over to you after that for sure. How do I bring this up? There it is. I have like 100 tabs open, and I just randomly came across this one. Thought this would be good to look at. Inside 0-point energy, Mr. Thomas Vallone has degrees in electrical engineering and physics as a professional engineer. He is the president of the Integrity Research Institute in Washington, D.C., providing technical consultation for engineering and law firms. Blah, 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 blah. 1999. 1999, guys. So a lot of people don't realize like electrical engineering goes, or the 0-point energy, free energy goes really far back. I'm just going to read through this. For the first time in history, a lot of media attention is being paid to the sea of energy that pervades all space. For the record, I only skimmed some of this. I didn't even read all this. You notice that a lot of what I've been saying on my live streams and what have you is consistent with what a lot of these people are saying. And that's just because this is science that's been out there. I've independently discovered this. He'll be at Tesla Tech in August. Oh, wow. Awesome. Well, this is I keep happening upon all these people that are big players in the game, right? And it's a matter of understanding and changing your perception of how you think our reality is formed. This is why I think that it's not wrong, but it's a little bit of a detriment if you have a classical thinking from book learning perspective, because the textbooks in the United States are missing big aspects of the universe in general. And if you learn it traditionally, then you're going to think that these things can't be possible. Like I constantly get in arguments with people in either YouTube channels, in my replies and stuff with people that are just insistent that 0-point energy is real, but there's nothing we can do with it, which is honestly just stupid. Like, obviously, we know the Casimir effect. You can see it on the screen here. We're going to get into it in a second. We know this stuff exists. It's like saying, like, oh, well, kind of goes back to the telephone. Well, only ignorant people think that you can transmit voice over wires, and if you could, there'd be no practical use for it. It's like, what are you talking about? We could transmit voice over wires. We don't even need wires for transmit voice, right? Like, it just goes to show that, we get stuck in this caveman like thinking that we have to kind of break out of. So, sea of energy that pervades all space. Richard Feynman and John Archibald Wheeler calculated the amount of energy in an area of space, and they found out that it's basically enough to boil all the Earth's oceans, right? Pretty wild. Just happens to be the biggest sea of energy that is known to exist, and we're floating inside of it. The Sea of Energy by T. Henry Moray. I need to write that down. I've heard T. Henry Moray mentioned a lot. So that's where it comes from, huh? Not only is it big, but its energy is estimated to exceed nuclear energy density. So even a small piece of it is worth its weight in gold. What is it? Many people are not sure what quote unquote 0-point energy is. Again, this is 1999, guys. 1999. This is 25 years ago. Most agree that virtual particle fluctuations contribute to it, and van der Waals forces don't explain everything. So van der Waals forces are the forces between atomic particles. So it's not enough, right? My daddy is not Steve Forbes. I used to argue when I was younger that Steve Forbes was my uncle to people, just to mess with them. Does it offer a source of unlimited free energy for homes, cars, and space travel? Depending on who we talk to, 0-point energy can do everything, and 0-point energy can do nothing useful. So this is really the type, if you were to talk to Thomas Bearden, he's going to say that 0-point energy is free energy. I imagine if we were to talk to Hal Puthoff, who has a number of papers on 0-point energy, he would say that it can do everything as well. If you were to talk to someone like Neil deGrasse Tyson, he would say that it can't do anything. We know it's there, but there's no possible way to take advantage of it, right? And this is the spectrum of opinions that we have out there. So when you're judging somebody based on their understanding of science, in my opinion, you should judge them based on what do they think about 0-point energy? Is it that we can do nothing with it? One thing, I think the smartest people on the planet, you know what they'll tell you? They'll tell you that nothing is impossible. That's what the smartest people on the planet will tell you. If people tell you something's impossible, then they're probably not as open-minded as that they think they are. How can the energy be converted into useful forms? What are the basic explanations of 0-point energy and the new discoveries, which have rocked the U.S. Patent Office, Physical Review Letters, Science, Scientific American, and the New York Times? Why is 0-point energy implicated in the largest confirmation of cosmological anti-gravity? Why? Because 0-point energy can help us explain what? Dark matter and dark energy, which are just terms that we came up with. We just invented dark matter and dark energy because we can't explain what we visually see. Because again, science is the study of observable reality. Can the Casimir effect be a source of energy? This article is intended to give review of the latest developments. So the Casimir effect. I don't know if we're going to read all of this. I just want to see what we got down here. Oh, we're definitely going to read the sonoluminescence part. I did not see that. Oh, look, and here's Hal Puthoff. Literally, Hal Puthoff gets referenced in here. Hilarious chat. We're just gonna read a few of these paragraphs. I'll put the link in the chat. You guys can check it out yourself. If you find anything great, reply on my Twitter post. I may make a Twitter post about this afterwards. There it is. Even if there's a limited amount of energy, the amount of energy, because the universe is so big, is just going to be massive. Absolutely massive. I do think that there's practically unlimited energy available to us. Okay. So 0-point energy has been called the ultimate quantum free lunch, 1997. During the early years of quantum mechanics, Paul Dirac theorized that the vacuum was actually filled with particles in negative energy states. So this is already where I think about the vacuum of the space-time ether as an oil well that we have simply not tapped into, thus giving rise to the concept of the physical vacuum, which is not empty at all. Quantum mechanics also predicted that invisible particles could become materialized for a short time, and these virtual particle appearances could exert force that is measurable. There you go. There's your free energy right there, everybody. Right? Hendrik B.G. Casimir, 1948, not only predicted the presence of such a force, but also explained why van der Waals forces drop off unexpectedly at long-range separations between atoms, predicting that force equals F equals K divided by D to the fourth. Okay, we'll skip through some of that. Though the Casimir effect subsequently was verified using non-conductive plates, there was always a scientific need for verification of the Casimir force using conductive plates based on Casimir's 1948 paper. For the first time, Dr. Lamoureux, now at the Los Alamos Labs, interesting, Perform the experiment with less than 1 micrometer, a micron, spacing between gold-plated parallel plates attached to a torsion pendulum. 1997. In retrospect, he found it to be one of the most intellectually satisfying experiments he ever performed, since the results matched the theory so closely, within 5%. The Casimir effect has been posited. I can't even say the word right. As a force produced solely by activity in the vacuum. The Casimir force is also very powerful at small distances. Besides being independent of temperature, it is inversely proportional to the fourth power of the distance between the plates. So that means the closer the plates get, it gets significantly more powerful, exponentially more powerful. Posited. I literally can't say it. I'm trying, guys. Try it. Therefore, as the plates are brought closer together, the virtual particles outside the plates increasingly overpower the decreasing quantity of the virtual particles appearing between the plates with exponentially increasing force. Okay, well, that's what I just said. Also notable is the fact that the frequency dependence is a third power, and the force can be altered with dielectrics or resonate with narrow band mirrors. Oh, that part's really interesting. That's 1997 again. Lamoureux's results came as no surprise to anyone familiar with quantum electrodynamics, QED, but they serve as material confirmation of the unusual theoretical prediction that QED predicts all-pervading vacuum continuously spawns particles and waves that spontaneously pop in and out of existence. So the part here that's important, I think, is continuously. The vacuum is continuously spawning particles. So why is that important? Because going back, posited. Yeah, okay. I'm done with that part. John Mackin applied a wave dampening to make an anti-snorting device. That's funny. That's hilarious, actually. It's too funny. This is important because my analogy of the oil field, like there's always this oil bubbling up. And then the question is, we can see the oil bubbling up, but can we posited? Okay, we're done with that. Can we pump an oil well in, or if we can we pump the oil out? Can we make a device that can pump that energy out? That's really the question. Their time of existence is strictly limited by the uncertainty principle, but they create some havoc while they bounce around during their brief lifespan. The churning quantum foam extends throughout the universe, even filling the empty space within the atoms. So there's your space-time ether right there. The quantum foam is filling the space between the atoms. What is that? That's a medium. All waves require a medium. What's the medium of electromagnetic waves? Well, I guess you could argue the space-time ether. A diagram showing the shape of nothing, 1997, is pictured to not only subatomic, but sub-elementary particle in size. Physical theorists predict that on an infinitesimally small scale, far, far smaller than the diameter of atomic nucleus, quantum fluctuations produce a foam of erupting and collapsing virtual particles visualized as a topographic distortion of the fabric of space-time. I mean, what does that sound like to you guys? It sounds like to me like you got to bring back Kaluza Klein. I think it's pronounced Hawk to it. Hawk 2. The Hawk 2 girl, she's real hot right now, chat. So hot right now, Hawk 2 girl. Another implication for free energy from zero-point energy comes from the fact that the Casimirs also mentioned a three-dimensional volume effect, 1956. This has recently been used with the relativistic stress energy tensor to analyze the quantum electromagnetic field inside any volume. With a relatively simple calculation, it has been shown that as the electron density increases due to gravitational compression, there is energy creation. Interesting. Well, now I'm interested. As the electron density increases due to gravitational compression, there's energy creation. Wow. What does that remind you guys of? That reminds me of Salvatore Paius's patent. The pairs of dynamic fusors create a concentrated magnetic energy flux and electromagnetic radiation within the vacuum changer, whereby concentrated magnetic energy flux compresses the mixture of gases to create a plasma. Interesting. Sorry, I had to switch to that. Seems interesting. The energy output produced by the Casimir effect during the creation of a neutron star turns out to be sufficient to explain nova and supernova explosions. New Scientist 1987, Why Atoms Don't Collapse, gives an impressive endorsement of the importance of zero-point energy. Shad and Sherry just asked me to come back on their podcast. I haven't been on their thing in a while. There is a dynamic equilibrium in which the zero-point energy stabilizes the electron in a set ground state orbit. It seems that the very stability of the matter itself appears to depend on an underlying sea of electromagnetic zero-point energy from 1987. Why the atoms don't collapse. Huh. Yeah, so that you could argue there's some type of equilibrium, right? In terms of matter, all the matter around us that's sitting on this sea of the space-time ether, of energy, of the medium that we want. I'm like infested by these little bugs. Hate summertime chat. Just looking through some of the questions here. Ashton's explaining why your microwave food is still frozen in the middle despite the following cooking instructions. That's funny. Inertial navigation systems and laser ring gyros. Yeah, maybe that's EJ Sawtooth for the laser gyro, I think, right? So another option is the Lamb shift. So Willis Lamb. Okay, I think we're going to skip that part. Let's look at the classical vacuum. One of the best educational viewpoints on zero-point energy is being by Timothy Boyer in an article, The Classical Value of Vacuum. Maybe is that 1985? A well-published and highly respected physicist describes all the features to be expected from zero-point energy, including the frequency spectrum, even in a moving reference frame, as well as energy and force. Boyer traces the historical creation of the vacuum as proceeding in stages in parallel with the historical development of ideas about the vacuum. To paraphrase, he says in the 17th century, it was thought that a totally empty volume of space could be created by simply removing all the matter, in particular, all the gases. This was our first concept of the vacuum, just get rid of all the gas. It became apparent that that region still contained thermal radiation, but it seemed that the radiation might be eliminated by cooling. So the second concept of getting a real vacuum is to cool it down to zero temperature, just go all the way to absolute zero. Then we've got a real vacuum, right? Well, since then, both theory and experiment have shown that there's a non-thermal radiation in the vacuum and that it persists even if the temperature could be lowered to absolute zero. That's 370 Kelvin, I forget, 270. Therefore, it was simply, there's 0 Kelvin. Sorry, 0 Kelvin, 0 Kelvin. Theoretically, therefore, it was simply called the zero-point radiation. This is where the term zero-point energy comes from, guys, is that because if you cool it to absolute 0 Kelvin, there's still radiation there, even though we would argue that we've achieved a full vacuum. Further proof is evident, as Dr. Forward points out in his tutorial below, When physicists have cooled helium to within microdegrees of absolute zero, it still remains a liquid. So that's helium-3, superfluid they're talking about. Only 0-point energy can account for the source of the energy, keeping the helium from freezing. Yeah, so helium-3 becomes a superfluid, does not freeze. Oh, interesting. Another aspect of the vacuum that is constant virtual particle flux of the vacuum 0-point energy can become less virtual, short-lived, near the boundaries of the bigger particles, with the atomic number of Z equals 137 or higher. This is because the intense electric field gradient causes more precipitate decay of the vacuum when the binding energy equals or exceeds the rest mass of the electron. Furthermore, if super heavy atoms are created with Z equals 173, the binding energy then exceeds twice the rest of the mass of the electron, and the pair production ensues with matter and antimatter appearing out of the vacuum. I think that's related to superconductivity. Could be wrong. The electron is driven into the nucleus, and spontaneous positrons, anti-electrons, are produced, constituting a true source of free energy. Paradoxically, the vacuum near an overcritical charge is a vacuum that cannot be emptied. Such a physics discovery vindicates the provocative name of Infinite Energy magazine, which has provided a forum for cutting-edge energy discoveries. It is interesting to note that the above-mentioned phenomenon was first labeled the Klein paradox, when the Klein-Gordon equation mysteriously predicted the reflection of an electron with more energy than the incident with the simultaneous transmission of the particle into a negative kinetic energy state. Negative energy. Only if the voltage barrier exceeded 2 mc squared, 2 times the mass times the speed of light squared, or twice the particle's rest mass. Is that Kaluza-Klein? I think that's the same Klein as Kaluza-Klein. In retrospect, this paradox helped physicists decipher a free energy source, much as I hope the runaway solution of the Lorenz-Dirac equation will do someday. Wow, crazy. Yeah, guys, like, I don't know if Eric Hecker's out there. I should probably email Eric Hecker. Eric Hecker needs to know that there's a reason why there's 450,000 gallons of supercooled helium-3 superfluid. I have a very good idea why. And it wouldn't surprise me if it's related to some type of gravitational wave detector. That's as much as I feel comfortable saying. Okay, we're going to skip the tutorial part. Let's look at the cosmological 0-point energy. Let's see what that one's about. 0-point energy was mentioned in 1998 in an article called Breakthrough of the Year. 2 teams of astronomers have confirmed that distant galaxies are accelerating apart. Furthermore, 2/3 of all astronomers now acknowledge the data is valid. Thus, the cosmological constant envisioned by Einstein is being reconsidered and an anti-gravity force being postulated. When did dark matter even become a thing? Was dark matter not even a thing back then? I think it should have been, right? Physicists have also interpreted the force as the evanescent particles that flicker in and out of existence in empty space that give space its springiness, shoving it apart. Dark energy. Scientific American seems to agree. The aggregate energy represented by these virtual particles, like other forms of energy, could exert gravitational force, which could either be attractive or repulsive, depending on the physical properties that are not yet understood. So are you starting to understand how we can have free energy and how we can create anti-gravity? Definitely high frequency gravitational wave detector, in my opinion, Jeremy. And the reason being that we don't need a high low frequency gravitational wave detectors because we have stuff like LIGO. Low frequency gravitational wave detectors would be used to measure stellar objects like a neutron stars that are colliding. High frequency gravitational wave detectors would be used to measure laboratory produced gravitational waves. Now, why is that important? Because if any other civilization or our civilization has figured out how to manipulate gravity, they're going to be doing it through high frequency gravitational wave production, not low frequency gravitational wave production. Although theoretically you could produce both. So if we have high frequency gravitational wave production, we want to have a detector that can detect high frequency gravitational waves. So I would postulate, and I don't know this for a fact, that Antarctica probably has a high frequency gravitational wave detector. They're either calling it something else or they're just not revealing those capabilities. And that would actually explain why we are hiding. We don't let anybody go to Antarctica. We don't want anyone to see that. We don't want anyone to figure it out. Because why? Because once you figure out we've got high frequency gravitational wave detectors, you go, why? And then you go, oh, okay, because people have figured out anti-gravity, or gravity manipulation is a better term for it. If you want to know more about that, I would suggest reading Bob Baker's article, paper about high frequency gravitational waves. I think it's called The History of Gravitational Waves, presented in like 2003, just a few years after this paper. The Bob Baker paper on gravity waves is it's mind-blowing, guys, in terms of what it can do. And it goes back to what I said at the beginning of this stream in terms of, like, if you're interested in figuring out gravity manipulation, look at Podklanov and look at Ning Li, right? The big three, in my opinion, are Podklanov, Ning Li, and then maybe Amy Eskridge. I mean, I don't know that she really got an opportunity, but, you know, she was definitely looking at their work. So it's out there. Let's see. I might already be pushing it with saying as much as I'm saying, honestly. Let's see what else we got here. Okay, here we go. The aggregate energy represented by these virtual particles, like any other forms of energy. Oh, okay, I already said that part. The cosmological constant represents energy inherent in space itself, and coincidentally is almost exactly equal to the average energy density of normal matter in the universe, 1 gram per whatever cc, some unit here, at this particular time in its evolution. To help explain the concept raised above, it is important to mention that the repulsive Casimir force may be experimentally obtained in a laboratory by utilizing a cavity built with a dielectric and a magnetic plate. I think he's talking about the Thomas Townsend Brown effect, right? The T.T. Brown? Could be wrong. If not, then this is basically the basis for EM Drive right here, guys. So I think what we're going to do, instead of doing EM Drive tonight, we'll end the stream after this paper, and then on Friday, we'll look at EM Drive. I'm going to look at the history of EM Drive. I want to look at Charles Buhler's version of it. The reason for that, if you watch the clip, actually, I'll play the clip here right after this for EM Drive. That's how we'll kind of finish it. Yeah, there's people alive that are expanding on that work too. I probably have a pretty good idea who some of them are, for sure. Yeah, I mean, people are definitely working on it. Like, look, if we figured out gravity manipulation, not everybody's dead. The problem is the people that are smart enough to have figured it out are shutting the hell up about it. Even Ning Li disappeared for like 20 years. I mean, that's the reason. Because once you've figured this stuff out, and let's say you start producing gravity technology for the Department of Defense or their contractors, you know, you got to get smart. I mean, people don't mess around with this stuff, man. Like, this is serious business, what we're talking about here. This isn't like, you got to be very careful what you're doing. Hey, Chad or Sherry, nice to see you guys. Yeah, I'm happy to take questions. I'm learning more and more. It's getting very interesting. Yeah, it wouldn't surprise me if some of the people that I'm working with are maybe involved in some of this stuff. There's a big connection between a lot of these concepts that are out there. There's definitely a major connection between 0-point energy and gravity manipulation technology. I think it's undeniable, the connection. And it makes sense too. Like, even going back when I was investigating MH370 videos a lot, you find out that there's always this requirement of these huge energy sources. And when you look at all the science around it, you always seem to find that every time you look at gravity manipulation, there's always, the mass was reduced in this object, like the Hutchinson effect. And you know, you see that there's clearly some connection. This is the reason why they have to hide every aspect of this. Like, remember when I'm going to just shit on Kim.com again real quick, because in the Stephen Greer space, he says, why won't the aliens Why won't the aliens just give us the cure for cancer? So, like, why doesn't the government just give us the free energy? Well, because even if they give us the free energy, then they have to give us the gravity manipulation, because once you figure one aspect of it out, then physics is going to figure all the aspects of it out. You know, that's the sad truth. That's why I don't think they're ever going to reveal this. Like, I don't think the government's ever planning on revealing this. Eventually, people are going to figure it out. Maybe it'll be the people like the APEC guys, like Jeremy here. Have a good night, brother, if you're taking off. Thanks for hanging out in the chat tonight. Appreciate you, man. Yeah, it's a scary world, man. It's a scary, scary world we're living in. Okay, let's see what else we've got. Experimental 0-point energy. Okay, I think we can just believe that we know that there's experimental 0-point energy. I mean, look at the dates of these papers: 1997, 1984. A corkscrew, or here we go. Dr. Forward describes this parking ramp style corkscrew or spring as a 0-point energy battery that will tap electrical engineering from the vacuum, allowing the charge to be stored. How funny is this? I mentioned that one of the ways where you might be able to produce an over unity device without having moving parts would be manipulating the Casimir effect by some kind of spring, right? You have the things very close together so that you can create this kind of compression. And then you can manipulate that and use that as your energy source. Kind of wild, huh? Yeah, there you go. The spring tends to be compressed. I mean, look at this. This is nuts. The spring tends to be compressed from the Casimir force, but the like charge from the electrons stored will cause a repulsion force to balance the spring separation distance. It tends to compress upon dissipation and usage, but expand physically with the charge storage. You might actually be able to make a free energy device out of this with no moving parts. I think that makes a lot of sense. Okay. We're going to skip through some of this because I'm starting to get a little bit scared. Starting to get a little bit scared. Might be saying a little bit too much. Might be pushing. I don't want to push the free energy thing a little too far. It's already in a sketchy spot. Okay. Let's take a look. Okay, the first 0-point energy patent, Dr. Frank Mead. What year was this? 1996. From Edwards Air Force Base. Okay. Wild. Yeah, I think we're very close. Charge density is created through the compression of the EM field. Makes sense. Yeah, truth is, guys, like, I'm trying to be a little bit careful about how far I push it nowadays. Like, I think I've pushed it far enough, and I'm already 1,000% convinced this stuff's real. So, like, I'm not doing this to convince myself. I'm doing it to have a better, more intuitive understanding and to help convince anybody else and you guys out there to drive you guys towards the answers. But I feel like there's probably some people that don't want me to do that. Maybe some people do. Okay, so Edwards Air Force Base designed receivers to be spherical collectors of 0-point radiation with hemisphere reflectors to beat frequencies. He stated that 0-point electromagnetic radiation, which may potentially be used to power interplanetary craft as well as provide for society's other needs, remained unharnessed. Spherical collectors of 0-point radiation with hemisphere reflectors of beat frequencies? What does a spherical collector sound like to you guys? Sounds like an orb to me. Sounds like an orb. Man. This is wild. Where did I find this? I feel like months back somebody sent me this saying check this thing out about 0-point. I've had this on my computer for months and I've never looked at it before today. And I'm glad I didn't, because I don't know that I would have understood it before. Proposing to convert 0-point electromagnetic radiation to electrical energy, Dr. Mead grapples with the high frequencies that may extend up to around 10 to the 40 hertz. This is very similar to Salvatore Pais' work. This is very similar. Yeah, an asymmetrical capacitor. I have to look into asymmetrical capacitors. I feel like there's also a connection there. I had that up. That's been on one of my tabs here as well for months and months. Asymmetrical capacitors. Because one thing that Charles Buhler mentions is, like, creating the asymmetry. So you take your Casimir plates, right? You got your Casimir plates and you get them close together. What if you turn one of your Casimir plates sideways? Now you've got a cone. Then what happens? Where's your force? What direction is your force? Because you have a pressure differential down here versus up here. So now you're going to get a force, I think this way. I could be wrong. And that's where you can have this acceleration force even in the vacuum of space. I think that's the main idea behind the EM drive. To gain a perspective, gigahertz radar is only 10 to the 10. Visible light is 10 to the 14, and gamma rays reach 10 to the 20. Oh boy, so that's huge. With slightly different sized receivers, the system produces a beat frequency. A difference frequency is produced with the rest of the circuitry amplifying the lower step down frequency. For example, if 1 part in a million accuracy was achieved in making the microspheres, then subtract 2 of the 10 to the 20 hertz signals would yield a 10 to the 14 hertz beat frequency. Okay. Okay, let's see. Similar to the passive mirror article cited above, Mead realizes the physical design of the conductor will determine the resonant characteristics. Remember semiconductors and superconductors, guys? Why are they so important? They're like a key aspect in this technology. If using large spheres, then it would resonate with a very long, low energy frequencies. Remember, the spheres are giant, right? Like 30 feet in diameter in the MH370 videos. However, he points out if this is miniaturized, then the frequency cube dependence goes up very fast. The energy density is much higher. Huh. The implications are that not only can it be made in a solid state device, but the smaller you make it, the better it is. Huh. Okay. The New York Times simply calls it the quantum foam. So if you hear the term quantum foam, that's the same as the space-time ether or the just the 0-point energy that we see around us. Well, if you've just been following for a month, then you've got a lot of catching up to do, but I'm glad you're here with us. This is actually a really good follow-up to the it's a really good follow-up to the video we were just watching. How have they directed? It could be from the right-hand rule in electrical engineering that determines the vector. Can also be due to some quantum entanglement effect. Whoa, well, that just broke. My poor rubber bands. Quantum entanglement effect, quantum entangle. Like that kind of effect. And that's the reason why I have this 4 orbs sign up here. Ashton 4 orbs. But we don't know for sure on why they do that, on how they determine the vector. But that's what we expect. That's what we speculate. Yeah, they banned the word ether. We're bringing the word ether back, though. I don't even care how many haters don't like it. Too bad. If you disclose super advanced technology, you can bring back whatever words you want to. Okay, does sonoluminescence? Well, here we go. Where are my casual sonoluminescence enjoyers out there, guys? How funny is this? So basically, everything that I've been saying on these podcasts is all being supported in this paper from 1999 that I never read before today. Awesome. It goes to show that great minds think alike. Like people that understand these concepts, this would not be, if this was fake, you wouldn't have all these people independently coming to these same conclusions. Yeah, the Holcomb system, my guess would be they're using some sort of like curled spring-like Casimir force because it doesn't use moving parts. That's probably what. I could pull up the rainbow mantis shrimp, but I think we're not going to do that for today. It's pretty cool, though. Yeah, the little shrimp does produce sonoluminescence. It produces this thrust. The punchy shrimp guy. Okay, maybe I'll pull it up. Hold on. What is it called? Punchy shrimp? What's his name? Rainbow mantis shrimp. Cavitation, right? Cavitation. Videos. Mantis shrimp. Oh, here we go. Okay, here it comes. Presents. Okay, we'll stop screen. Punchy shrimp guy. Where is it? Where is he? Oh, here it is.
There are hundreds of different species of mantis shrimp,
Okay, well,
and they live all over the world. It's kind of crazy how those. Thank you.
I don't know. There's supposed to be
Force,
something.
which
Anyway,
is like-
whatever. Well, we don't have time for it tonight, guys. Sorry, but I tried to find it there. Okay, inside 0 point energy. Let's get to the rest of the stuff here. So, does sonoluminescence tap into it, though? That's the question, right? And I had already speculated it does. I think that probably 0 point energy, or I'm sorry, the star in the jar is kind of equivalent to cold fusion at the very small scales. And cold fusion also taps into 0 point energy. I think that stars are probably tapping into it as well. The chemical effects of ultrasound explains as 1989. And remember, I posted a link or a video from Hal Puthoff as well. So I can play that. Here it is.
This is a conversion of vacuum energy into another form, in this case, light, heat, radio waves. So we know of a laboratory that has some experiments going in which they were creating turbulent bubbles in fluids and then measuring the energy in the water by the heat, and they were getting over unity efficiency. And so we have now arranged to have those devices shipped to our laboratory, and we're going to do a very detailed study. But in this case, we're talking about kilowatts of excess energy.
Not 1 watt.
Right, kilowatts.
That Hal Puthoff, he looks like he's got to be 40 years younger. That'd be like 40 years ago. That was probably like the 80s. I mean, you could see they had old school projector. Like they had those when I was a little kid. They stopped using those in like the 90s. One punch shrimp. Yeah. Okay. Let's keep going. And it's funny that the very next paragraph talks about Hal Puthoff as well. There's enough energy in the 1 mile per second shockwave to tear electrons off the vapor atoms in the water, ionizing them and heating them to light emitting levels. Apparently, the presence of argon dissolved in the water is a crucial ingredient for the visible ultraviolet light to glow so brightly. Critical to understanding of nature of light in the spectrum, however, is whether it matches the known spectra of ionized gases. Claudia Eberlein, and this is 1996, Sonoluminescence and QED, Quantum Electrodynamics, describes her conclusion that only the 0 point energy spectrum matches the light emission spectrum of sonoluminescence, which is therefore must be a ZPE phenomenon. Oh, wow, Yahtzee chat. This helps explain products such as Griggs hydrosonic pump, whose water glows blue when in cavitation mode, that consistently has been measuring an over unity performance of excess energy output. Is this what Hal Puthoff was talking about? How are people not talking about this? 1996 patent? This is a really good this is a really good link, chat. I'm going to post the link again one more time. Holy shit. What the hell? I mean, this is where I just like, guys, how many over unity devices and patents need to be out there before people start taking it seriously? It's ridiculous. Like, come on, man. At some point, I just feel like, well, how do I have to work so hard to convince people? I'm posting a link to the Discord for people that want to join as well. I'll probably post this link on Twitter after I get some food after this stream. There's the Discord link. The Post article also discusses the possibility of heat being sufficient for cold. There it is. Literally every single thing I've mentioned is just in this article. It's just like, and this is from 1999, and I didn't even read this whole thing before this. The Post article also discusses the possibility of heat being sufficient for cold fusion and reviews the movie Chain Reaction featuring Keanu Reeves. That was the movie where there's the clip where Morgan Freeman tells Keanu Reeves they've been hiding it because the energy is because it would change everything. This movie is highly recommended because it's the first movie ever made to actually mention the words free energy. I didn't know that. The movie, which also featured as a cover story for Infinite Magazine, shows a demonstration of a cold fusion cell and the concept behind the frequencies and power availability to make it threatening. Holy shit. What I find, I'm gonna watch this movie tonight. What I find memorable is Morgan Freeman, who acts as the banker. He's going to say the exact thing, isn't he? He's a variable archetype of JP Morgan. When he talks about the concept of energy, he says that's a noble concept, but it would cause the collapse of the world's economies. Dude, this is weird, chat. This is the... If there's any evidence of time travel, I'm wondering if this article is evidence of time travel. Did I go back in time and write this article? It's starting to get bizarre now. It's actually just getting weird now. Am I this guy? Who is this guy who wrote this? Is this me? Did I change my name? Holy shit. If I go back in time and write this article, I'm going to put like something else in there that's going to talk about Discord. If you find the random word Discord in here, then we know I went back in time and wrote this article. Okay. Sonoluminescence and cavitation create the necessary shock waves to access zero-point energy, but some scientists claim that 100 times more heat is necessary to create fusion. That low-energy nuclear reactions would disagree. However, some cold fusion scientists who use high-pressure cold fusion say that they have achieved that requirement. Hello? Like this one right here that we're reading right in front of us by our buddy Salvatore Paez. Like with this thing right here. This one. Like that. Okay. Robert Hiller calculation: black body equivalent of the sonoluminescence radiation corresponds to a temperature of 100,000 degrees Kelvin. Julian Schwinger from the Schwinger limit. Basically, the surface of the bubble is supposed to act as the Casimir force plates. As the bubble shrinks, it starts to exclude the bigger modes of the vacuum energy, which is converted to light. I mean, this is the mother load, guys. If you understand exactly how zero-point energy works, like this is the mother load. You're looking at it right here. This is the mother load. This paper this document we're reading explains all of the science behind it. This has reference links to I don't know how many patents we've already seen and huge number of physicists and electrical engineers. Scientists at UCLA have recently measured the length of time that sonoluminescence flash is persistent. Barber and Putterman discovered that it only exists for 50 picoseconds or shorter, which is too brief for the light to be produced by some atomic process. Yeah, so it can't be a matter of the atom splitting the atoms, is what they're saying. So therefore, zero-point energy must be the source of the radiation. Well, there you go. This is literally right here. This paragraph directly connects, if not proves experimentally. This one right here basically proves that sonoluminescence must come from zero-point energy. This links cold fusion directly to zero-point energy. There you go. Cha-ching. Okay, let's see what Hal Puthoff has to say. I think we'll do 2 more paragraphs, and then we'll probably call it. Oh, we're at the end. Dr. Hal Puthoff is a physicist who has continued to develop Dr. Andrei Sarkinov's theories of gravity and inertia. What he has achieved, which is now causing shockwaves even at NASA, is that this is 1999. This is 25 years ago. Is that gravity has now been theoretically proven to relate directly to zero-point energy. Holy shit, chat. A fascinating new theoretical imagery is presented. Hal Puthoff in his paper, Gravity as a Zero-Point Energy Fluctuation Force. No wonder these guys have been paying attention to me. Holy shit, chat. Oh, I'm getting goosebumps, chat. This is weird. Oh my God. Because gravity is just the stress in the medium, right? Gravity is your stress in your medium. For my people who are new, right? What is gravity? It's the stress in the medium. And what is the Casimir force? Is also just a version of the stress in the medium. And it's related directly to the 0 point energy. The sea of energy creates our universe, all the stuff that we see around us. Everything that we see around us is an interaction between all of the mass and energy that we see around us and the 0 point energy field, otherwise known as the space-time ether that we see around us. Hit Control F and type the word Discord just to see if I accidentally wrote this. I'm afraid, actually. I'm actually afraid to search. It shouldn't be in here, right? There's no reason they would say the word Discord, right? Okay, it's not in there. The reason why I came up with that word is that Discord would not have been invented in 1999. They would have no reason to say the word Discord. Oh, shit, chat. Okay. He points out that gravitational mass and its associated gravitational effects are shown to derive in a self-consistent way from electromagnetic 0 point induced particle motion. I mean, I'm reading this paper later. The Zitrabuagong. This is interesting because Sal Paez and Dave Rossi and Hard Truths podcast number 4 mentioned the Zitrabuagong, or the particle jittery may be jittering, yeah, may also be the result of 0 point fluctuation. Puthoff believes that it constitutes an already unified field. He refers to the gravitational text by Meissner, Thorne, and Wheeler, that's John Archibald Wheeler, often used into graduate courses of general relativity. There are basically 6 approaches to gravitation that are outlined in the book. The one that Dr. Puthoff emphasizes specifically is the Sarkhanov. In the paper, Gravity is 0 point fluctuation force. I don't gotta Google that. Definitely pulling up. I probably have this paper somewhere. Yeah, there's Puthoff. How do I find PDF? Oh, come on, man. There we go. I was like, don't be stingy, man. Why are these scientists being stingy with their scientific papers, you know? Let's see. It's not even the scientists that I blame. I think it's the published review locations. He points out that Sarkhanov regards gravitation not as a fundamental interaction at all, but as an induced effect that is brought upon by changes in the vacuum when matter is present. Oh my God. Yes. I love Hal Puthoff, guys. I love this guy. And I love that they tried to discredit Hal Puthoff. Oh man, no way am I letting that stand on my watch. We're going to vindicate Sal Paez. We're going to vindicate Hal Puthoff. They try to claim that these people are quacks or whatever. I'm going to vindicate all these scientists. I don't care how long it takes. They're going to get vindicated for sure. The fascinating part about this is that the mass is shown to correspond to the kinetic energy, the 0 point induced internal particle jittering, while the force of gravity is a long-range effect. Low frequency, long-range forces are now associated with van der Waals forces. Van der Waals forces are seen in colloids and various other liquids weakly interacting. In Puthoff's theory, gravity is related directly to 0 point fields by the low frequency end of the 0 point radiation spectrum. When we consider 0 point energy as having a third order dependency on frequency, it reminds me of the Hutchinson effect, which has also been shown to be a third derivative third order effect. The Hutchinson effect is used to explain an object, conducting or non-conducting, which repels gravity under the influence of a high voltage AC modulated DC fields, with the object continually and uniformly increasing in acceleration. Scientists have never seen that happen before, except in the third order Lorentz-Dirac equation treating radiation reaction, which may help explain the Hutchinson effect. Forces in nature tend to create a constant acceleration due to F equals ma. Force equals mass times acceleration. The third order effect predicted by the equation of motion in Puthoff's paper is directly related to 0 point energy, also yields an insight into the Hutchinson effect. It's also worth noting the free energy that races 0 point shows the evaluation of Hutchinson effect by the U.S. military, who promptly classified the report. Okay, well, now I'm pretty sure the Hutchinson effect is legit. Is this a link to it? We're going to look back at that. A key to the Bermuda Triangle in Vancouver? What? We'll have to look at that later. Okay. So, guys, the thing too about Puthoff is, right, like Puthoff, I'm sure. I mean, he in the Eric Weinstein, Jesse Michaels interview, I mean, Puthoff basically said he's been working for third-party defense contractors. Like, you guys have to realize these people that work on the defense contractors, they know way more than the public knows. They've seen the stuff and they have NDAs and they can't talk about it. So if Puthoff is writing papers like this and he's like, yeah, here's 6 options, this is the one I like the most, probably should pay attention to that. Probably should pay attention. Yeah, this is going to be spicy. John Hutchinson, huh? It's like he figured it out. Look at this. This looks like Bob Greenier's stuff right here. Oh, man. There's so much to go through, chat. We could spend a whole lifetime looking through this stuff and never get to all of it. Okay, inertia is the zero-point energy effect. The Lorentz force is used to describe Faraday's law. For example, when we have a charged particle moving in a perpendicular magnetic field and use the right-hand rule to describe where the magnetic field is going to force that particle to go. So for the person who asked where the plane goes, the orbs are circling clockwise around the plane if you look at it from the front. If you use the right-hand rule, this would indicate the vector travel of the plane where the particle is going to go is going to be backwards. In this example, the electric field, the magnetic field, and the force are all perpendicular to each other. Yeah, so the curl of the magnetic vector, you have your electric force, and then you have your the force of the actual particle. The Lorentz force has now been proven by Puthoff in his derivation in Physical Review 1994 to be directly responsible for what he calls the electromagnetic resistance arising from the known spectral distortion of the zero-point field in accelerated frame. Physicists often hear that Einstein was very interested in Mach's principle. Ernst Mach was a philosopher more than a scientist and developed a concept that we can only understand inertia if we have something unmoving reference frame. That's because everything is relative to one another. He chose the distant stars as the reference frame. This has been interpreted not only by Einstein but others since then to actually explain the principle of inertia, since the distant stars can be regarded as a relatively stable reference frame in the universe from our perspective. Puthoff states the zero-point field could thus serve as the Machian cosmic reference frame. And the interesting point is that the bulk contribution to the effect in this case, the inertial mass, comes from the very high frequency components of the zero-point energy field. Wow. So the mass itself comes from the zero-point energy field. Holy shit. So that would explain gravity, because mass is directly related to gravity, right? Then he demonstrates a causal and quantifiable basis for Mach's principle and explains that magnetic component of Lorentz force arises in zero-point energy and matter interactions. Okay, well, what paper? Where does he talk about this? Basically, read everything that Puthoff's ever written, guys. Got to read everything that Puthoff's. Unfortunately, he's like 86 or so. So, yeah. So if you can add mass, then you can lose mass, right? Yeah, John Hutchinson. We may need to find, if you can find any good documents on John Hutchinson, it would probably help. I'm more interested in Puthoff, though. Yeah. You need to understand coordinate systems and position in 3D space. That's why I think a lot of times they talk about quadrupole, because you need to figure out, like, how do you take your block of energon, your block of space, in order to talk about, like, how far things are from one another. It's pretty wild. Newton's laws is okay. We might have to read one more paragraph. Another theoretical breakthrough that I put off is the derivation of Newton's law from zero-point energy electrodynamics. It appears to be related to the known distortion of the zero-point spectrum in an accelerated reference frame. We therefore have an understanding of why force and acceleration should be related, or even for that matter, what is mass. Puthoff explains that resistance to acceleration defines the inertia of matter, and it appears to be an electromagnetic resistance. Holy shit, man. No wonder you can reduce inertia, right? Because you can manipulate this force. If you're manipulating this force, you manipulate inertia. Inertial mass reduction for a transmedium craft. Guys, Sal Paez, the interview that I had with Sal Paez might go down in the history books. People just thought this was mumbo jumbo. It's fucking crazy, man. Salvatore Paez. Insane. 2016. Holy shit. How did that get out? How did these patents get out? They probably had to cover it up. Okay, let's figure this out. To summarize, the inertial effect is a distortion at high frequencies, whereas the gravity effect has been shown to be a low frequency effect, according to Puthoff's theory. Maybe. It is important to mention that doctors Ruda and Heisch have also contributed to this field by proposing to have found an explicit origin for the reaction force of Newton's second law, which has traditionally been attributed to their inertia. Their article in Physical Letters, 1998, proves that the acceleration-dependent scattering of the zero-point energy radiation, which the accelerated object is forced to move through, interacts with standard electrodynamics to cause the Lorentz force of the object. Oh, wow. Okay. Okay. So what they're saying is that, remember this. Okay, I have a good analogy for you guys. Ready? So this microphone right here, right? When I touch this microphone, I'm not actually touching it. What's happening is the electrons in my finger are bouncing off the electrons or being repelled by the electrons in the microphone itself. So I'm coming extremely close to it if we were to go look at it, but I'm not actually touching it physically. So imagine that there are electrons everywhere in the zero-point energy field. When we're walking through that field, there's a resistance factor. So that resistance factor is theoretically what gives rise to mass, is what I think essentially this is saying here. Is that that's what mass means, is that we have this effect that of all matter everywhere interacting with one another. It's still everything that we understand about gravity is still true. It's just a matter of how we look at it, right? Just a matter of how we look at it, how we understand it. And it's really important because even though most of physics as we understand is already correct, it's a matter of changing our perspective. You change our perspective, and now we can manipulate gravity because now we understand what's going on. We understand that there's an interaction between all the electrons that cover my body and everything else that's around us all the time. The resistance is just very low, but there is some type of resistance that's there. Interesting. Very interesting. Boy, this has been a good science stream. Every science stream, I feel like I learn a lot. Okay. Cool. Their work cites Puthoff, and it was supported by a NASA contract. So here's the other thing, too. All of a sudden, NASA's giving these people contracts. All of a sudden, third-party defense contractors are giving these people contracts. It's because they know some shit. They're figuring it out. The distortion of the zero-point energy field under acceleration is the cause of inertia that we feel from the bound electron. There it is. Are you sure I didn't go back in time and write this? This is weird. The distortion of the zero-point energy field under acceleration is the cause of inertia that we feel from the bound electrons in our body reacting to the sudden change of direction. Holy shit. You just said the exact thing. That's from Puthoff. I mean, okay. Holy shit, chat. Yeah, please say that again. I'm going to read this one more time. The distortion of the 0-point energy field, everything all around us, under acceleration is the cause of inertia mass that we feel from the bound electrons in our body reacting to the sudden change of direction. So it's the same idea again as this microphone here, but with just everything all around us all the time. That's what gives rise to mass and inertia. So if you can separate yourself or manipulate that effect, then you can manipulate inertia, you can manipulate mass. Wow. Just wow. Perhaps there is a way to prevent. Okay, guys, I'm pretty sure I wrote this article from the future or went to the past and wrote this article at this point. I mean, didn't I just say this? Perhaps there is a way to prevent that interaction. I just like, what is going on right now? This is so weird. Maybe there are some ways that we can actually turn on a dime, accelerate really quickly, and take off on a space drive. Yeah. How about the MH370 orbs? They're inertial mass reduction devices as well. Now I'm 100% sure. I mean, I'd already kind of figured it out. Superconductive harmonic orbs. That's what they are. They're hypersonic too. Superconductive harmonic orbs. This is what Arthur C. Clarke believed constitutes a space drive in his new book, 3001: The Space Odyssey. He specifically cites Puthoff's theory with the idea that it is written in the 3001 era, looking back 1,000 years as to what the most breakthrough news might be in space drive. Okay, well, I guess we got to finish this up because it's crazy part. If I had read this ahead of time, guys, I probably wouldn't even have gone over this today. I feel like this is, big Yahtzee moment reading this. I don't think it says too much, but it definitely connects the dots. Certainly, such an impressive theoretical achievement as Puthoff's cannot go unnoticed. Philip Yam, in Exploiting 0-Point Energy, 1997, addresses the issue critically. Energy in a vacuum is very much real. Specifically, 0-point energy emerges from Heisenberg's uncertainty principle, which limits the accuracy of the measurements. Residual energy must therefore exist in empty space. And given the equivalence of mass and energy, the vacuum energy must be able to create particles. They flash briefly into existence and expire within interval directed by the uncertainty principle. He then goes on to dryly summarize the Casimir effect. You're going to hear the Casimir effect over and over and over. And Puthoff's research with a demand for proof of principle. Dr. Mark Millis of NASA's new Breakthrough Propulsion Physics Research Program has also addressed the above emerging technology in several articles in the past year, including his challenge to create the space drive. There's research in 1997. Man, this is so old. There's search for asymmetrical modifiers. There you go. So this is them. They were already on to EM drive way back then. Asymmetrical modifiers leads him to consider the remaining research of the 0-point energy field, which he calls the ZPF, because of its high energy density. Electromagnetism is also suggested as a target phenomenon for space drive research because of the 0-point energy field. The ZPF is an electromagnetic phenomenon. Discovering any way to react asymmetrically with the ZPF would likely create a space drive. I mean, this is funny. Here it is right here. This right here, free and bound charges, right during this part, this is Charles Buhler right here talking to 1 day ago, July 9th, talking with Tim Ventura. Right here, he actually talks about they know it works and they don't understand how it works. Well, Charles Buhler, if you're out there and you're watching, you probably should just read this list right here. This will explain how and why it works. Maybe Charles Buhler knows, but like, let me do the face. Right? Like, where are we at here? Come on, man. Just read this, Charles Buhler. Furthermore, he concludes these theories provide new alternative approaches to search for breakthrough propulsion physics. Perhaps we can start a new trend by blaming everything on 0-point energy, pronounced zippy. No, we're not pronouncing chat. We're not pronouncing it zippy. That is never happening, chat. Yikes. Yikes. Okay, now I know I didn't write this because we're never calling it zippy. Not in this life or the next life. It's going to be ZPE. For interesting theoretical physics paper on zero-point energy, download this. No way. That's a risky click, chat. That's a xxx.lanl.gov. That's a risky click right there, chat. No, thank you. Lastly, Dr. John Bershaw from the Institute of Advanced Study at Princeton, where Einstein works, says we're all quantum fluctuations. That's the origin of all of us and everything in the universe. Ooh, I love that quote. Love that quote, chat. Okay, guys. Wow. That was a wild. I did not expect that link. I'm going to post it one more time. Crazy link. That was great. Thank you guys for listening and watching tonight. So Friday for sure now we're looking at EM Drive. EM Drive on Friday. We're going to watch probably a couple clips from Tom. Oh, I said we would watch. There was another clip I said we would watch at the end here. I've already forgotten what it is. Let me look. It'll come back to me. What was the clip, chat? Sibbers we watched. Huh. There's the Pudov over Unity. I don't remember what the other clip was. Crap. Oh, it was the Glenn Beck, Charles Buhler one. Here, this one. Let's watch this real quick.
Electricity itself has energy because there's energy between charged particles. We're all familiar with the Coulomb energy, like particles, positive particles repel, negative particles repel, but plus and minus attract. We're all familiar with that aspect of static electricity. What this has shown is that there is what we call electrostatic pressure in the presence of the field. It's basically the pressure itself, which is not something I invented. That's been around for 100 years or so. But the pressure itself can act in such a way that if it's unbalanced, it can give you a net momentum transfer to your system.
So when he talks about unbalanced, he's talking about asymmetrical, your unbalanced system.
That's what's new. And how exactly this does this?
It's not new, though.
I don't know. I'm not sure if I'll ever know, but it seems to work.
Wow. So he doesn't know how it works. He should probably watch this stream. Charles Buhler should probably watch this stream if he doesn't know how it works, because I think we just explained it pretty damn well in this link that we just showed here.
This is easy to manufacture. It's easy to test. Now, we've done all the testing in vacuum or in the lab. Now it's time to take the next step and put it in low earth a little bit and see what it does. Okay.
So tell me the ramifications, if this is found to be what you think it might be. Tell me how our life and the things that it could do and would change.
Well, clearly, it would revolutionize transportation as we know it. All forms of transportation. Cars, boats, trains, planes, everything would change. You wouldn't need an engine. You wouldn't need a combustion engine or to burn fossil fuels. You wouldn't need propellers or wheels or tires. It would just revolutionize everything. Yes, it would revolutionize everything if we can get this much above unity. Right now, we're sort of
above. Sorry, what? Above unity? What if there's any other terms for above unity? How about over unity?
Hovering around unity, but you need a little bit more to carry something.
Glenn Beck definitely had his mind blown during that interview, which I think that it's great that he had that interview after he talked to me, because he probably was thinking back to some of the stuff that I was mentioning to him as well. Big thank you to Jamal. Appreciate you, man. Appreciate everybody who watched the stream tonight. Great science stream. Loved it. Thank you, MH370X. Everyone have a great night. Now watch our closer here. I'm going to play us out with the cipher that shows the videos. Now watch these videos again, because when we watch these videos with this understanding, we have a much better understanding of what these orbs are and what's going on in this video. Thanks, everybody. Peace.
Out in the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. exit points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Unknown forces balancing the plates, creating the throat, open the gates, from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear. Exploring the cosmos, our future's here.